In this video, we learn to approach remainder problems when divided by 7 quickly and easily. Coming up. The first stage is a tutorial. We learn the basic concept of approaching remainder problems when divided by 7. Let's go for it. Welcome to tutorial. If 2 to the 7th power is divided by 7, what is the remainder? There is a mathematical approach called cyclicity. When an exponential number is divided by 7, it is divided by with a certain pattern that repeats. 2 to the first power divided by 7 has a remainder of 2. 2 to the second power divided by 7 has a remainder of 4. 2 to the third power divided by 7 has a remainder of 1. 2 to the fourth power divided by 7 has a remainder of 2. 2 to the fifth power divided by 7 has a remainder of 4. 2 to the sixth power divided by 7 has a remainder of 1, and so on. So you can see that we have a cyclic pattern of 2, 4, 1 repeated for remainders when divided by 7. Pay attention to the number of power. Because we have a cyclic pattern of 3 numbers when dividing base number 2 by 7, figure out the order of power in terms of 3 chunks, and you can figure out the remainder easily. It will be 2 or 4 or 1 depending on the order of the power. 2 to the 7th power divided by 7, then we'll have a remainder of 2 because the order of the cyclic pattern will begin again at the remainder of 2 for the 2 to the 7th power. The answer is B. Now that we cleared the tutorial, let us solve the GMAT level problem. The first stage is a 400 level question. Pause the video and try to solve this question. What is the remainder when 2 to the 40th power is divided by 7? An exponent of 40 is a large number. From tutorial, you learned that there is a cyclicity of 3 pattern when divided by 7 for an exponential number with base 2. 2 to the first power has a remainder of 2 when divided by 7. 2 to the second power has a remainder of 4 when divided by 7. 2 to the third power has a remainder of 1 when divided by 7. And the pattern repeats. So now we have to find out which order the power of 40 will fall into. In order to find out which order the power of 40 will be for the cyclicity of 3, find out the multiples of 3. 3 multiplied by 13 is 39. Since the power of 40 is 3 times 13 plus 1, the remainder must be 2. Same is the case of 2 to the first power. The answer is D. Let me improvise this question quickly to help your understanding. What is the remainder when 2 to the 42nd power is divided by 7? The power is 42 and it is divisible by 3. Since it is divisible by 3, it must have the same remainder as the case when 2 to the third power is divided by 7. The answer will be remainder of 1. What is the remainder when 2 to the 33rd power is divided by 7? The power is 33 and it is divisible by 3. Since it is divisible by 3, it must have the same remainder as the case when 2 to the third power is divided by 7. The answer is the remainder of 1. What is the remainder when 2 to the 22nd power is divided by 7? The power is 22 and it can be expressed as 3 times 7 plus 1 when you write down in terms of multiples of 3. This means it will have the same remainder as the case when 2 to the first power is divided by 7. The answer is the remainder of 2. Good job! You cleared the first stage. Now let us solve a more difficult question at 500 level. Are you ready? Pause the video and try to solve the question. What is the remainder when 996 to the 111th power is divided by 7? Now we have a big base number 996. Express 996 in terms of multiples of 7. 142 multiplied by 7 is 994. So 996 is 142 times 7 plus 2. In this question, 996 to the 111th power is the same as 142 times 7 plus 2 to the 111th power. Since any exponent of multiples of 7 is perfectly divisible by 7, we don't have to worry about the multiples of 7. We only have to consider the last part, which is 2 to the power of 111. What is the remainder when 2 to the power of 111 is divided by 7? From previous question, we already know that the remainder has a cyclic pattern of 2, 4, and 1. Express 111 as a multiple of 3. 111 is divisible by 3. How do you know that? You add each digit of the number and see if it is divisible by 3. 1 plus 1 plus 1 is 3. and thus 111 is divisible by 3. By cyclicity, this 2 to the 111th power has the same remainder as 2 to the 3rd power when divided by 7. It has the remainder of 1. The final answer is A. Congratulations! You mastered the map of a remainder with the divisibility of 7. In summary, follow these steps. First, find out the cyclic pattern when divided by 7. Second, see if the base number has a multiple of 7. If it has a multiple of 7, it is divisible by 7, and you can exempt this number when considering the remainder. Third, find out the order of power in terms of multiples of the cyclic pattern. For example, base number 2 divided by 7 will produce 3 cyclic patterns of remainder 2, 4, and 1, so you should find out multiples of 3. I hope you got the concept of solving remainder problems when divided by 7. Don't forget to subscribe and like the video and have fun with the dividing numbers.